Good morning and welcome to the Ford CSR update, where Ford has got a deadline for suppliers to use FMEA software. I think all of you are in for a treat. We have a very excellent panel here. I'll introduce them a little bit later, and let's get started. One second here as I turn on my video. Okay, a brief introduction to Omnex. I know many of you already know who we are, but we still have about 30% of our audience is new every time we do this. So we're headquartered in Ann Arbor, Michigan. We have 16 offices worldwide. We say 21 sometimes, depends on whether we count the 4 India offices or the 4 China offices. And what are we very proud of? We help write many of the standards we in the automotive industry use today, including myself many years ago, helped write QS 9000. I did the first worldwide witness audit for what is today's IATF 16949 in 1995 when it was called QS 9000. We are members of the AIAG writing committees. Actually, you have 2 of the 6 or 7 writing committee members here, Mr. Greg Ruska and Mike Down, who have been nice enough to join us here today. Well, they're part of Omnex, but we invited them and they've joined in. And we have 700 employees working globally, helping to implement various different standards and initiatives of OEMs and Tier 1s. All right. So these are the 6 target markets for Omnex. Of course, all of us are in automotive. We do a substantial amount of work in aerospace, semiconductor, and high tech. About 50% of the car is going to be electronic or software. Well, that's by 2030. So you can imagine there's a tremendous amount of work we have done in the past and today in the high tech industries. We also work in medical devices and general manufacturing. You might see here, many years ago, we clearly recognized the electric vehicle and autonomous vehicle markets. You might be, good for you to know, we have 30 to 40 different training deliverables for different competencies for EV and AV that you might want to avail of yourselves. Go on. So this is what we're going to talk to you about today. The idea of foundation FMEAs, family FMEAs, and part FMEAs. And couple other things we're going to talk to you about. Of course, Mr. Mike Down will talk to you about the reverse FMEA that he so loves to implement and do, and he trains. And we'll finish up talking to you about innovations coming from Omnex on linking requirements, about how we do AIAG-VDA FMEA, and also something called the multi-point FMEA. So a little bit about myself. I'm the CTO of Omnex. Today's webinar, what I'd like to really tell you is I've been shepherding the Aqua Pro in the enterprise-wide quality management systems, integrated and quality management system software since its inception in 1988. So the software we're showing you today came out first in 1988, also because of Ford Motor Company. Ford had a standard called Q101. Some of you might remember it. And the first 2 questions were on FEMAs and control plans. The other thing I'm quite proud of is coming up with the linkages of process flow, PFEMA, control plan work instructions, and then DFME and DVPR. But I had a very able support from Mr. Greg Ruska. Greg, you might think of as the sort of the grandfather of coming up with all these linkages. He helped Ford Motor Company come up with what is called the DCP, initially called the Dimensional Control Plan. And before that, he wrote a book called CP Squared that talked about the FMEA control plans and control plans needing to be very comprehensive. What year was that, Greg, when you wrote that book?
85.
1985. So he is a forerunner of much of today's FMEAs. We are joined by Nikhil Unikrishnan, who is going to show you the software. He's a project manager for electric vehicle and autonomous vehicle projects. We are doing a number of EV/AV projects, from everything from automotive spice to 26262 to functional safety. Folks, that's why we're able to look at this, look at the FMEA and talk about the FMEA DVPR linkage and talk about the implementation of the V model. And then we have Mr. Mike Down. Mike was a lead for the AIAG, not just the 4th edition, but also all the 5 different core tools. He was a lead. With that, this is the agenda for today. I already talked to you about Omnex. I'll start by talking to you about Ford CSR requirements, and then I'll turn it over to Nikhil to run the slides, and then Mr. Greg Gruska is going to talk to you about foundation FMEAs, and then segments and how AquaPro helps do FMEAs, and then Nikhil will show the EWQIMS suite. Greg, Nikhil will be showing the software just once after you do both your sections, okay?
Yes, that's all right.
Great. Next, we'll be talking to you about as a discussion between the different experts here today. We'll talk to you about AIAG-VDA FMEA and the SAE J1739. Maybe this is the first time you're hearing about SAE J1739. We'll talk to you about that. It's a new SAE FMEA. And then Nikhil will come back and share with you, the AquaPro software, doing AIAG-VDA FMEA. Then Mike will talk to you about the reverse FMEA, and then we'll finish up with the innovations that the industry needs today. All right, I took a long time doing that. So this is the first section we're going to talk to you about: foundation FMEAs, family FMEAs, and part FMEAs. So here it is. This is coming straight from the CSR. Let me start really. Family FMEAs, Ford wants you to do. They want to make sure you get permission from Ford when you do that. But foundation FMEAs and part FMEAs are a must. They need, for any programs which is not, where the job one is not completed by July 1st, not only do you need to buy the software, but you need to have all of those part FMEAs by July 1st, 2022. Very aggressive, it's a big ask, but that's what they have, which really means you guys all need to act today. Now, when you look at this, foundation FMEAs and part FMEAs can be both for design and process. Ford is asking it for the PFMEAs, all right? And then you have to continue on populating and updating all your FMEAs in the software by the end of the year. So you can see here the requirements for the Ford CSR. At this point, Nikhil, let me turn the presentation to you. And let me also introduce Mr. Greg Gruska, who is part of the Core Tools Supplier Task Force member for the 4th edition FMEA. Go ahead, Greg.
Thank you, Chad. All right, let's go to the next slide. Okay, you switched presentations. Okay. All right, foundation FMEAs. It turns out foundation FMEAs is, in concept, nothing new. In the past, people have called it corporate, generic, baseline, best practices, and whatever. And Omnex AquaPro has been referred to it as global FMEAs because they cover all the different products and processes that you have. But these are being called foundation FMEAs in the Ford CSRs, recognizing that they do have these other terminologies. And the foundation FMEA really is the accumulation of information. From the very beginning, the logic in the FMEA manual has been that you need to keep the FMEAs up to date whenever you make a change in the process, you make a change in the product, you find information with respect to problem solving. And so it's always been around, but people haven't really been doing that well. So what Ford is coming down is saying, all right, you're going to do it. We're going to be using the foundation FMEA as being this living document. It's going to capture the information specifically for the different processes. Although foundation FMEA both deals with design as well as process FMEA, Ford CSR tends to focus more on the process types rather than the design, although it does refer to the different design. All right, next slide. So they present the generic content of the FMEAs. And as such, they are thought of being used as a starting point for specific FMEAs. And from that standpoint, they could also make have less of a workload for the specific FMEAs, specific product FMEAs, because you do have a lot of that information pre-done. Now, again, that has always been around, but the basic assumption is that you keep the FMEAs up to speed, up to date. And unfortunately, that wasn't always true. When we go in for audits or improvement to a lot of processes and we ask to look at the FMEA, they go in the file drawer and blow the dust off the files because nobody's taken a look at it since they had submitted their PPAP. And so the FMEA is not really up to date. So in this case, the foundations must present the experience and knowledge that we have had in the past, why we did what we did. They look at it over the entire service life. So if we do have a field failure and we have to make modification, because of that, we want to go back and update the FMEA. Again, that has always been part of the problem-solving approach. When we are looking at, if you will, the 8D, where it says in D7, we're supposed to look at other processes in that. So we need to update the documentation. If you look at effective problem solving, CQI 20 from AIAG, they actually say, look at the FMEA when you're doing your problem solving. So the foundation FMEA definitely can reduce the cost of creating your FMEAs. Now, that is with adequate software. I mean, we said, well, but we're using Excel. Excel is software. And the answer is yes, but it does not have the linkages between the foundation FMEA and the specific FMEA. So with that, with the cascading, be able to cascade, FMEA can reduce efforts by as much as 80%. And so when we use the reuse. All right, next slide. So CSR, Ford CSR says that organizations are required to have foundation FMEAs. And again, foundation FMEAs without software is useful, but not very efficient. Because if you do not have the software to align the foundation to the family, to the individual product, that means that somebody physically has to go through each of the individual documents. They are a critical role in the prevent recurrence process, the 7D7 to split across. And if you do use the foundation FMEA and do the linkages, then you can actually have that happen automatically. But we need to remember, and this is stated in the CSR, that they are not a replacement for family FMEAs or part FMEAs. So they are the total conglomeration, which we call global FMEAs, or of the total, but you still have specific applications which are in the family or part. Okay, next slide. So when we look at families, this is specific applications, if you will. We are the only difference between the parts and the families are dimensional, not form, application, or function. Whereas the foundation tend to be process oriented and really could have all different types of parts, because really we're looking at how are we controlling the process, or how are we adding into the parts itself. And Chad did mention before is that if you do use family process FMEAs, you should get a forward STA review and concurrence prior to the use. And if you're doing that in design, you should get forward product design review and concurrence. But essentially global, the foundation is something that has information for all the families. So we can look at it as the cascading, that we are starting off with the hit enter, Nikhil. The global is what we call in Aqua the foundation FMEAs. So that is the start. So we put our requisite information on that. So we do that, and then that cascades down to the family parts. Our next slide. Now, the Ford CSR also talks about the information flow and linkages. And this, again, is one of the reasons why you need the software, is because if the part and the foundation FMEAs are to be living documents, they must be aligned. Can you do this alignment manually? If you do Excel, certainly you can. You would probably have to have somebody working full-time to assure that any change made in the foundation will be cascade to all the parts that are using that foundation FMEA. So the update in the foundation shall result in a review of applicable information for the part. In addition, the FMEAs also need to be aligned to the control plans. The FMEAs, and this is in the FMEA 4th edition, the FMEA shows the control methods. The control plans details what those methods are, the how many and the how often, and what are your reaction plans. And that information also needs to go to work instructions and visual aids. So the CSR says the software supplier shall use FMEA software, which ensures the alignment of the foundation FMEA, the part FMEA, the control plan, and other applicable documents. So the more capability you have in your software package you're using, the easier it is, the more time you can save. And notice it does also refer to special characteristics. We have to be able to have the cascade. So a special characteristic in the FMEA or DFMEA needs to be made available to the process flow, FMEA, and control plan, which is a requirement, not of the CSR, it's a requirement of the APQP, PPAP documentation. Okay, next slide. So this is again what Chad has said, so I'm not going to spend time on it, that if forward model programs which have not yet completed job 1 by July 1st, 2020 need to use the software starting July 1st, 2020, all foundation PFMEAs and subsequent updates to all FMEAs must be available on the FMEA software starting December 31st. And as Chad said, this is quite aggressive to be able to do that. So you need to start looking and considering how you're going to do that now. Next slide. So we can look at it. We've seen this before, that the global, the top is the top level of products and families will share this information. We use the term inheritance instead of cascading or anything like that. So from the foundation, we go down to the family. The family is the start, is the foundation of itself, or the start of a family structure. Then all children of these parents will share this information. And so cascade down, next slide. So a parent can have a child or multiple children, and you can actually continue the inheritance or the cascade down into grandchildren and great grandchildren. It depends upon how much reuse you're going to do and what is the modification.
Hey,
The
Greg,
yes, sir.
we need to mention at the family, you can edit things and add things for that part family. In a child, you can add extra characteristics, tools, processes. So can a grandchild. And the big idea is if you change the family, all the part and the grandchildren change, right?
Yes.
And in this way, you can take your 8D and update the family and have all the many 30, 40 part numbers running around the world all change at one time. Go ahead, Greg.
Yes, you can. As it turns out, I personally like the analogy between parent, child, and grandchildren, because as you know, you do have some children or grandchildren that they inherit from the parent. However, they don't have to keep it. They can make modifications. And so that is the capability. Just because you inherit something from the parent doesn't mean you can't, and we use the term override that requirement. You may have a special need in the child itself or the grandchild. So you can do the overrides on that. Okay, next slide. All right, one of the things about, and Fort CSR specifically gave the example of the different process types, the mill, the drill, and so forth. You could put it all together in one big FMEA foundation, foundation FMEA. However, there are some companies that have a collection of standard processes on that. We have a client that does injection molding, and they have different types of brands of machines to do injection molding. And instead of putting it in one foundation FMEA, where then they would have to delete the machines where they don't have, they utilize what we call process segments. And what the process segments is that instead of having the foundation of all the processes together, we do it by the process type. All right, next slide. So for example, you can think of it as a tool room. In a tool room, you have a bunch of standardized operations, and yet a given part will go take different paths through that. So if you're creating a flow, FEMA, or control plan, you essentially use the information for each of those individual segments. So we create foundation FMEAs for receiving, for milling, for drilling. And then next slide. Next slide. And then for a given product or family or product, then you put them together in a library of best-in-class processes. So you could have, in this case, we just have one mill operation, but we could have 2 different milling operations, depending upon what it is that you're doing. You can do the segment at the parent level. And if you do it at the parent level, then all the children will also inherit the same segments, or you can reorder the segments, as it were. So what this does is that provides you the ability to have consistency in the control plan by machines, and yet very rapidly come up with the process review documentations, the flow, FEMA control plan, because the system, the software, will put it all together once you've identified the segment map itself. Now, this is dealing with processes. Next slide. But you can also do the same thing for design segments. So we could analyze the different process functions and requirements, and then we can do segments within the design itself. So that includes all the unique functionality, requirements, testing, and analysis. And the design segments create a best-in-class design library. Next slide. Now you can, products can use the same segments to develop their own process and products. So you do this by selecting the features in the segment map and in the document menu for the product. So you can pull it down. You don't have to do a whole lot. You point and click. If the process segments are used at the family, any child, subfamily, or products will inherit the features of the parent. This includes all the segments. But the children can have their own unique segments in addition to the inherited ones. Next slide. So once the segment map is complete, you can change any of the inherited information, as well as to add new branches to the developed process documents. The key thing to remember is that inheritance only goes down. So you need to do planning on how you design your processes when you go through. Now with that, I will turn this over. No, I got one more slide. Okay. So inheritance and process segments, they do make it faster to create new parts and make it possible to update groups of parts simultaneously. So inheritance and segments are a way of sharing process information between different parts. So if a change is made in the parent or the foundation, it would also be made in every child, unless, of course, the user does not want it to be updated. So you have the flexibility. You are not forced to do that. So there is a tremendous return on the investment in the Aqua Pro software with the design process reuse and design and process reuse using inheritance and segments. With that, I will turn it over to Nikhil, who will actually show you its use and Aqua.
Thank you, Greg.
All right. Thank you, Greg. Right. So you should be seeing Aqua Pro right now, just to confirm.
Yes, we can see it.
All right. Thank you. So in the Aqua Pro tool, we're going to see how the FOD CSR requirements can be effectively satisfied. So as Chad and Greg mentioned earlier, we have the foundation FMEAs, and Chad, please feel free to chime in and give additional pointers during the process. So at the global level, which we call as the, we have the foundation FMEAs residing there. You can see processes such as grinding, label installation, receiving, screening machine, and other processes all residing at the top. Now, if I were to see, for example, what the label installation is going to look like, I can open that up and see how that will be captured. And you can see that we can call these the process types that FOD refers to in their CSRs. So as we go down, you can see this is what the label installation can look like.
So in this way,
now, moving.
we have these global process types that standardize best-in-class processes globally in an organization with multiple plants all over the world. Go ahead, Nikhil.
Thank you, John. So with that, let's next dive into the part family FMEAs. And as I'm going to take the example of the battery module. And here, as you can see, we have, we're going to see what the battery module part family FMEA is going to look like. So as I'm opening this up, we can see that the battery module process FMEA has a process types such as receiving inspection and cell stack build and other operations all brought in together to help you build a part family FMEAs. So it becomes very easy to use because now at the battery module level, these were built together by the segments that we have also created at that respective level. So the ones that I just showed you, for example, the receiving inspection and the cell stack build and other operations all reside at the part family level.
So Nikhil, let me just share. It takes some from the global level, and then there's additional operations because battery modules are built in multiple parts of the world. It also standardizes the processes for the battery module in the family one. Go ahead, please.
Let me give one.
So from the part family level, we can further go to the part level here. So you can see the part number 1871 and other part numbers where it is, these are specific battery module part numbers. And at this level, we can again further have part-specific FMEAs. So as we've heard earlier, if you have changes reflected at the foundation FMEAs, it can cascade down to the part family and then from there to the part number level. Similarly, if you add changes at the battery module level, it can reflect to not just 1871, but all of the parts down below here as well. And to show that, I'm going to take you to one of the parts here. So let's take an example of the battery module and open up the process FMEA. All right. Now here, let me take you to the second operation, which is the cell stack build. And let's say I would like to change the preventive control here to something else. So the cell stack build operation, which has a potential failure mode of misaligned cassette hole pin, let's just change it to a different control method. So if I'm going to change it to something else and give it a rating, let's see how that cascades down from there. So I've added, for example, variables control chart from the battery module level. Now, what this means is if I go to 1871, which is a part number below that, and I open the process FMEA, I can see that the changes have cascaded down from the part family to the part number. So here you can see the changes for that same operation, self-stack build, with the misaligned cassette and hole pin having variables control chart listed as the preventive controls. Okay. So you can see that now if I go to the next part, and so if I let me open up the process FMEA for the next one, you can see the same changes that have cascaded down from the top. So let me just go down here.
While you're showing this, that the change could have been in a characteristic, could be in a spec, it could be a tool, it could be the effects of failure, whatever your 8D or a change management process drives into the FMEA, you can change in one place. If it's for a certain part, the 8D was a problem for the same one part, but in D7, you said it applies to all the parts. You go to the family and you make that change.
Excellent. Yep.
Cascades to all the part numbers.
Okay. So that shows you the effectiveness of how the inheritance concept is going to help you with change management and consistency from top to bottom. All right. And you saw how changes can also happen there. Now,
Nikhil,
I'm going to take you
one more instance. If you had a global change, let's say 8D on a part number ended up with a global change, you go to the global process segment and make that change, and immediately it won't just change it in a part family, it will change it in all the part families and all the parts. Very powerful. Go ahead, Nikhil.
Excellent. So with that, let me take you to also the concept of where we have design documents and how we can build in also horizontal traceability. So let me open up the FMEA for the battery modules, which is again the part family there. So if I'm opening up the FMEA for the battery module, and let's say I'm going down to one of the functions, which is going to help me with structural support. So for example, we have provide structural support for the cell stack. And there is a requirement and potential failure mode. And let's say I'm going to assign a characteristic and class for that. So I will go here and let me pick from the cell stack height, which is one of the characteristics. And this, we can categorize this specific characteristic for CSR, for example, to be a significant characteristic. Now, when I'm doing that, because of the horizontal linkage that ACOPro helps you with, when I'm making the changes here, and let's say I'm adding some preventive and detective controls here as well. For example, let's say follow a design guideline and with a certain occurrence number, and also let's say a detective control as well. So let's say like a crash test. All right. Now, if this is done, and I want to see how this is going to affect my DVPR and test plan. So you can see the controls will need to show up in the DVPR test plan. So let me go to the controls at the DVPR test plan. So as you can see here, with the provide structural support for the cell stack, now the function, the requirement automatically populates from your DFMEA, ensuring consistency between the two documents. Now, also, if I look at the controls, I can see that the two controls that I added in, like the design guideline and also the crush test, have also shown up in the DVPR test plan. Okay. Now, from here, I'm going to take you to show again the power of the tool where it can go from the design document to the process document as well. So as Greg mentioned during his session, it is an APQP requirement itself that we need to have the linkage between design documents and process documents. So let me go directly to our process flow for the battery module. So the process flow for the battery module has these operations. And we were taking the example of the cell stack build earlier. And let's say I would like to have a characteristic effect, be affected by this particular operation, right? So the same significant characteristic which talked about the cell stack height could be one of those characteristics that can have an impact here if you're building the parts together. So if I'm bringing that characteristic here again.
I want to just make a couple of points. This has been plaguing our industry, how to link design FMEAs and process FMEA. We showed you very easily how the software does it and how our methodology experts like Greg Ruska and Mike Dunn have helped us make this link between design and manufacturing. The other point I just wanted to say in a matter of trivial, just for you to know, this is the format that actually Ford recommended in the DCP, where you can see the multiple streams of variation, and you can also see the operators that are used so in a process. Okay, so this is what we think of as a best-in-class flowchart. Go ahead, Nikhil.
Thank you, Shad. So once we add the characteristic at the operation 20 here, because of the horizontal linkage between the process flow, process FMEA control plan, I'm going to show you how this would affect your process FMEA. You will see that in the process FMEA, again, we will have that characteristic show up as well. So that is very helpful, which is ensuring that it is automatically cascading down from your PFD to your PFMEA. All right. Now, let me add some controls at the PFMEA. So over here, I'm going to add, for example, let's say we have some poker yoke. That's been designed into the process. And then if I'm going to add that in, and let's see how that will also show up there. So if the DSM BFA poker yoke is added there, and let's say some sort of an operator check, for example, do some sampling, is also performed. Now, if that is done, I've added a preventive and a detective control here, all right? Of course, we would have also, if I'm filling this out properly, I would have like failure modes and effects and causes as well. But if I'm doing this, now the main thing I wanted to show you was how, again, it would link back into your control plan now. So let's open up the control plan to see how that shows up. So going down, you can see that the same operation here, cell stack build, has that significant characteristic showing up here. And also you can see those control methods showing up here as well. All right. So again, updates to the process FMEA automatically cascading down to the control plan as well. I'm going to take it one more step forward and show you how this will link to your work instructions. So let me open up the work instructions. So for this particular operation where we have the cell stacks build, you can see here we have the detailed work sequence or the steps of doing it, and also the characteristic that we added here also shows up in the work instruction. Now, if you have something like a safety characteristic, you know the importance of that being cascaded down to the work instruction level, right? And we also have the controls that we saw in the control plan also showing up here as well. And this also can go to your check sheets as well. So effectively, this helps you all the way from your design FMEA to your DVPR test plan, to your process flow, to your process FMEA control plan, work instruction, and then to your check sheets. So we can see that linkage established all the way across the board. Right. So Chad, do you have any more additional comments to add to that?
Go on, Nikhil. We can now go on,
Okay.
and you can come back and after the RFMEA.
Sounds good. So let me
Do the
present.
presentation.
Yeah. All right.
So we just saw the review of the software, and what next topic that we're going to do, and actually Mr. Mike Down is going to present. Let me share with you the Ford CSR requirement. Can you go to the next slide? So this is what Ford says, that organizations are required to have a process in place that ensures all new launches complete an RFMEA event. So RFMEA event for Omnex is something we call process reviews. We've been doing this for a long, long time, and definitely the software supports it. The goal of this RFMEA is to discover opportunities and implement improvements in the FMEA that you didn't previously discover, okay? And you can use the RFMEA event to actually help you with your foundation FMEAs and part FMEAs. Go to the next slide. And with that, let me turn it over to Mr. Mike Down, who was the lead for the Core Tool Supplier Task Force. Go ahead, Mike.
Thank you, Chad. The reverse FMEA is relatively new in the industry, and it's a tool to have continuous improvement based on site reviews and observations. So when you do a reverse FMEA, you're physically going out to the operation, you're looking at the different controls, you're looking at how the operators are doing their jobs, you're trying to evaluate using the PFMEA, have all of the failure modes been identified, have the causes been identified. Through the investigation, we want to make sure that the risk that was given to the different controls, the preventative controls and the detection controls are effective. Next slide. So the PFMEA, and we call it a reverse FMEA, and the fact that it's going to play off of the PFMEA, which it doesn't matter what formats used, whether it's the conventional format or the AIAG-VDA format. It's basically focusing on what preventative and detective controls were identified, what action items were identified. So when I do the reverse FMEA, a team will go in, and it specifically is operation by operation. So it's not just a walk through, you know, op 10 through op 120. It's actually taking op 10, and they might spend the day just looking at op 10. And it would be a cross-functional team that would be focused with expertise around whatever that op is. So if it's a milling machine or milling operation, it would be the experts around milling. And that team would look at the PFMEA, look at any action items that were identified. They also pull any 8Ds that recently had been on a similar process and make sure that this new operation doesn't have some of the same issues. So they'll go back, starting at the recommended action, it'll work through, look at the risks that were identified for the detection and prevention controls, and make sure that through testing. So basically what they're going to do is they're actually going to take a red rabbit or some defective part and see if the preventative or detection method will actually identify it. And if it if it leaves op 30 and gets all the way to op 80 before it's identified, then that's a big issue. So they'll actually let this red rabbit go until somewhere in the operation it gets identified as being a defective part. Hopefully not getting to the customer. Next slide. So the purpose of the FMEA is to improve the robustness by making sure that the preventative controls and detection controls are meeting those risk assessments that were done during the PFMEA analysis. So we're taking that PFMEA, and in actuality, the reverse FMEA team will be making an evaluation of how well the PFMEA was done. It may require the plant to redo or update the PFMEA for that operation if they don't think it was done well enough. You can't really do the reverse FMEA on a poorly done PFMEA. Next slide. So the team's really critical, and it's not really a walk through the whole operation, the whole system, but it's actually the team would get together and say, which operation are we going to review today? And they'd say, well, op 20, and then they might gather more subject matter experts and then fill out documentation that's part of the reverse FMEA process of what are we going to be focusing on as we look at this op 30, this milling operation, whichever one they decide to choose. And so the first thing they try to do is have all the potential errors been identified by the PFMEA. So they'll look at maybe they missed something when they did the initial PFMEA, and they'll identify that. Two, if a discrepancy does occur, how long through the system does it take to be discovered? So this is where we do the red rabbit. We actually are going to test whatever the preventative or detective control is and make sure it effectively can detect these issues. And then three, it may turn out that we discover new things, or maybe the risk needs to be changed, but there may be an update to the PFMEA based on this evaluation that the team makes. Next slide. So just in closing, this is kind of like an eye chart, but there's actually an 8-step process that goes through, develops brings together this cross-functional team for whatever operation we're focusing on, develop the paperwork to say, what are we going to be focusing on? And this can be done in AquaPro, and then go through and actually do an on-site. There's another document for doing this on-site review. And then there's going to be a final documentation, which is what did the team find and what updates had been made. But the big part of this is at the end, making these updates and making sure that the permanent preventative action is in place, and we're keeping this customer safe from any defects getting out of an operation or getting out of the whole process. I think the next slide, and that's
Nikhil. Thank you very much, Mike. Nikhil, let's go past this. All of you have seen when the changes are made, you can go back into AquaPro and make the changes you need. There's a lot of interest in AIAG-VDA, Nikhil. So let's go forward. And I'd like you to show the AIAG-VDA in the next section. Folks, you'll be very interested in seeing how we do it with the software. Can you go to the next slide? Oh, there it is. So folks, we are now going to sort of discuss, Greg and Mike, you want to talk a little bit about the AIAG-VDA 7 steps and maybe some of the improvements we have made with the software and also our methodology in the AIAG-VDA. Greg, you want to take a first crack at it?
Yeah, I guess I can. As you can see, the orange boxes are the standard 7 steps for the AIAG-VDA that's in their handbook. In doing it and actually trying to implement it, we found that it was really not complete. So we added some additional modifications to it. For example, in 2, as you could see there, we have require or add the P diagram and the interface diagram, which are very common requirements from customers, from OEMs, as well as the requirement for a block or boundary diagram. The focus of in the 7 steps is the structure development, which is useful, but the structure development does not show all the interfaces and interactions between the different elements of the product that you're using. And so it does not give,
Hey, Greg,
yes.
maybe I'll just add that the block diagram, one of the innovations we've done in the block diagram is, if you look at the entities within a block diagram, every time you draw an arrow between it, we automatically will create what is called an interface characteristic or an architectural requirement, okay? And then you can, so that's one of the innovations. And also, Greg, you very much you've said we need not only functions, but we also need requirements. You may want to tell why we need requirements. Go ahead.
Yeah, that's in part 3, or step 3.
We have to go a little bit quick because we're almost out of time.
Okay. The functions and reason why we're focusing on requirements is because we have found that in order to come up with the failure mode in a very systematic way and make sure that you have captured all the failure modes, you need to know what are the requirements, because the failure modes are really, if you very naive way of looking at it, is the opposite of the requirements. And on the right-hand side, the linking of the special characteristics to functions and requirements. There is an optional column in that you can do that as part of the AIAG-VDA, but not part of it, or not commonly done. And this is a requirement for PPAP, is that you have the special characteristics identified in the flow FEMA control plan. And then finally, the link to DVPR. The DVPR is not even mentioned in the handbook, but that is something that even the CSR, Ford CSR, talks about.
Let's go to the next slide.
Yeah.
And Mike, I have a specific question for you. Mike was a part of the SAE J1739. Mike, we have the 4th edition. We have the AIAG-VDA FMEA. Why did we need a SAE J1739?
Well, J1739 has always been the standard. So it's a standard. The AIAG-VDA is a handbook. And so, and the reference document at AIAG is a reference document. And basically the J1739 is the standard. And what we tried to do with that standard was work some of the developments that were made for the AIAG-VDA. So things that we didn't change is the J1739 is based on a common format that's very similar to the 4th edition reference manual. But we did replace RPN with the action priority number. Now, replacing that doesn't mean that you don't, depending on who your customer is, you may not have to eliminate the RPN. They may want to have RPN. You could do with RPN, but we also give the option to do action priority, and that's what's covered in the standard. We also updated the ranking tables to be similar to what that's AIAG-VDA, and we've included the MSR, which is the kind of the functional safety piece that's looking at monitoring and system response. So it's looking at mechatronics. And then it has a 6-step process that's been defined.
Hey, Mike, I'll just summarize if you have fourth edition and you have AIAG-VDA FMEA, the big complaint was the form itself on the AIAG-VDA FMEA. You have taken all the improvements, but you have used a form similar to the fourth edition, which is also what I want to share with the software. Nikhil, why don't we show the software and show both the different formats and how the Omnex software, by the way, folks, was developed in the 1980s when there was lots and lots of different formats. So you can change the formats at will. And so here it is, a design FMEA. Go ahead, Nikhil. Showing it in the fourth edition. And you can just go to the format table. And by the way, it satisfies Honda, it satisfies BMW, who's also required it, any different format you want. All you have to do is go pick AIAG-VDA. And immediately the format changes. Okay. So of course, there's some significant changes between the fourth edition and the AIAG-VDA FMEA. By the way, Greg will tell you fourth edition required it, but didn't mandate it. What is that? They require the links between the system, subsystem, hardware, software, which is a structure analysis, and the requirements flowing down, okay? So our software, once you do those two steps, you can pull up, you can do the fourth edition format without, and pull it up in an AIAG-VDA FMEA, which we think is a big deal. Do you want to show sort of the block diagram and I don't know what other tools you want to just show very quickly? And
absolutely.
We'll probably run a few more Q&A. We have questions, please share your questions. And,
so here, for example, I have the block diagram that is going to help you with the DFME. And I'm also going to be showing you, like Chad mentioned, in the process side, if you want to see the structural analysis, and if you would like to see, for example, how that looks, we can also see that as well. So for the fourth, the AIAG-VDA version, where it does talk about like the man, material, machine method programs, you can see all of those, how you can categorize that as well.
Because of time, Nikhil, let's move on with the presentation. Folks, if you want to see more about on the software, we'll be happy to talk to you and actually give you your team a demo. So go to the next slide. I want to just finish up by telling you what you looked at just was the DFME, DVPR, all the way to the control plan. But the power of the software is not just there. When you do the AD, it'll automatically link to the DFME or the PFMEA, which you can update. By the way, you can force this if you want, mandating it, or you can make it optional that the D7 step comes in and updates it. The MSA links to the control plan, and then the control plan and the check sheets and the work instructions, you can actually take out in a handheld mobile device if you want, and you can enter all the data in live or in a computer or a tablet on the shop floor, okay? So very powerful. Go to the next slide. So this is just to show you the structure analysis. Can you go to the next slide? All right, so again, one more slide. We're going to focus on this, and I'm going to show you the flow down of requirements, okay? From the pack to the battery management system, the hardware and software. Next slide. And you can just go a little, so you can see there how the requirements flow down. But this is the look I like, folks. So if you do the structure and the flow down, you can actually do the rest on a fourth edition format or a SAE J1739. And you can pull it up in any different format of your choice. Go to the next slide. Let me just say, today with mechatronics, electronics, and software, 30% of the failures are actually multi-point failures. Folks, we're the only software in the world that has multi-point failures built in. Thanks to the experts that we have in Omnex, they have recognized this, and this you will not be doing efficient DFMEA if you did not do a multi-point DFMEA. Go to the next slide. We also have linked DFMEAs, FMEA and FTA, very important for functional safety. Go to the next slide. Q&A. Great. With Q&A now, let's go to the Q&A. So here's a question from one of our participants, Greg and Mike. They are saying family versus foundation. Sounds like family is more design focused and foundation is more process focused. Is that right? You want me to answer this, sir? Greg or Mike? Greg?
Yeah, go if you want to answer it, you can, but I can answer it.
Go ahead, Greg.
Okay, the foundation is more generic. You can, the family tends to be focused on a specific application, if you will, or a part product. Yes, yeah, but you can still have foundation being on the design side and family being on the design side. You can have families of design so that you would just modify different features in the design, but the vast majority of it would be the same. So it's the foundation is a more generic, more open FMEA than a family. Family is more specific.
So Greg, in summary, will say both the foundation and the family can be both design and process focused.
Yes. Foundation
is global. Family is for the product family. With that, I'll move on to a second question. Is there a way for the part FMEA to approve or reject a change?
In Aqua, the part or the child can override or reject a change that from the family, from the parent, or the global. The design of the individual production item or part has total control over what it is. So the you can not accept. The system will want to make the change, but the design or development team can override it.
So we have a couple of customers who came in, said, good presentation, thanks for the valuable info. The tool makes most of our lives easier, more simplified, thanks. Now we have a customer, this is for you, Nikhil. Is the software, is it browser-based? And can it be local? They're saying, you understand the question, right? Go ahead.
Yeah. So I would say we have mainly two options of deployment. Either it could be cloud-based deployment, where you could access it anywhere from the globe as long as you have access to a web browser like Chrome or Internet Edge or Firefox or any of that. Or the alternate, where some of our customers who want it housed within their Intel IT framework, they would usually install it inside their servers so that you can only access it via their LAN, or if you're traveling, you might have to use your company VPNs. So we do support both of those options. Besides that, even single sign-on and other authentication methods are also supported by the tools.
So thank you, Nikhil. So the answer is we are both, and we can implement it the way you want to. Now, I will take this question on. Do the operators need to know how to use Aqua? so they can use a checklist in the plan of control? And the answer is no. If you use the inspection control, as soon as they put that part number, that checklist and the work instruction are the only things they will see. You can actually, you'll have a schedule and you can assign which process to which operator, and that's what they will see. And they actually, not only can they use the checklist, they can actually enter the data in, and we automatically will calculate CP/CPK actually for all the characteristics, okay? Why is ROI improved? Let me answer that also. ROI is improved because of reuse. So let's say, I mean, we actually save in our savings calculation, we save millions of dollars for a medium-sized company that, you know, has 40 or 50 people working on a project, because of, it's not just in the DFMEA or the PFMEA that you have reused. We have reused in all the documents coming out of this. Even in functional safety, we have reused. We have it also in cybersecurity, ISO 21434, we have reused. So tremendous, you know, you saw that inheritance and you saw the segments, tremendous reuse, and that's where the savings come in. Okay, we supply we are only a process supplier. Are we able to use the software? Greg or Nikhil, you can answer that. Do I need to be a design supplier also to be able to use our software?
No, you do not need to be. You could just do straight CLI. In fact, we probably got more people that are production oriented than they are design oriented using the software.
Another question, can we continue using Excel and satisfy Ford?
It's yes, you do have to do a lot of work though.
No, Greg, I think the answer has to be no. There are no linkages, so you cannot use Excel. It's not software, okay? Excel is just it's just a template. We have a comment from one of our participants. J1739, yes, we do see J1739 SAE. You know, it'll go into other non-automotive industries. It's commonly used standard that, you know, that it's not just for automotive, it's also aerospace uses SAE J1739. So big changes. And with that, I want to thank, you know, our esteemed, you know, Greg Ruska and Mike Down as part of the AIAG Core Tools Committee members. Thank you so much. And Mr. Nikhil Onikrishnan, thank you very much for your help in presenting the software and talking about it. I know you're very well aware of all functional safety, ASPICE, cybersecurity, and you're right. Let's finish up. This is the 7 levers of the automotive industry, where this is the Omnex focus on the electric vehicle and autonomous vehicle markets. Go to the next slide. These are the services we provide for these new industries that we are in. And continue on, sir. Maybe we'll stop here soon. And we have a tremendous amount of training that you all probably already know, and we do implementations. With that, folks, I hope you have enjoyed the presentation today. And thank you very much. And if you're interested in looking at the software, now the time has come that we have to commit and we have to adopt software, because we have to do the RFMEAs, the foundation FMEAs and the part FMEAs, okay, by July 1st. So time is of the essence. Thank you all very much. Bye-bye now. Thank you from Omnex.